Today we are learning our last theorem of the year. There are 3 theorems that we're going to learn all year long. Intermediate value theorem. We learned that one early on. Okay? Mean value theorem. That's what we learned on Friday. That's when we talked about the derivative is going to be equal to the average rate of change. And then today is probably the easiest one and probably the least used one, but you use it all the time. It's just common sense. Today we're doing extreme value theorem. Let's look here. It says the function g is continuous on this closed interval, with g of 1 is equal to 5 and g of 4 is equal to 8. So when in doubt, graph it out. 1, 2, 3, 4, 5. 1, 2, 3, 4, and then 4, 8. All right, I got these 2 points. The following, which would guarantee, when you see that word, guarantee, or there must be, that is a theorem question. As soon as you read guarantee or it must be, think, hey, what theorem am I using? Okay. On this one in particular, they say the derivative is 1. If they're doing a theorem and they're talking about derivatives, it's a pretty good chance you're talking about which derivative or which theorem. This is MVT. This is mean value theorem. The derivative is equal to the average rate of change. Oh, well, my average rate of change is 1. I could do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's 3 over 3. Oh, yeah, my average rate of change is 1. That's where this is coming from. That's mean value theorem. Which of these things would guarantee that that is true? B, because if I'm talking about mean value theorem, I have to be differentiable. It didn't say I was differentiable up here. It only said I was continuous. So in order for mean value theorem to apply, it has to be differentiable. It doesn't have to be increasing. It could be doing anything like this. It could be crazy lines. Doesn't matter. Okay? You could have, G has a maximum on the closed interval. That doesn't help me. I need to be differentiable. Okay? One horizontal tangent. That doesn't have to be true. I have to be differentiable. That's what I needed. Questions on that one? All right. Today, we are talking about extreme value theorem. Okay, extreme values of functions. Today's lesson is super easy. All right, I'm going to give you some difficult problems that make you do some mental math today. It's going to hurt your brain. But the concept itself is super easy. That's why I feel like I can give you some challenging things. So keep that in mind as we go through it. Okay, the thing I'm adding today is nothing. Here's what extreme value theorem states. Okay, here's what we're talking about. We have 3 graphs. This graph right here has a minimum and a maximum. An absolute minimum, that point right there is lower than the rest of the points, and that point right there is higher than the rest. You agree? This next graph, it's got a minimum, but it doesn't have a maximum. Okay? I think the maximum is happening right about here, but I can't tell you what x value that's on. It's something really close to 2, but it's not 2 because there's an open circle. It's like 1.999999999999999. But I don't know that. I had to stop eventually. It's not it. Okay, I'm really close to that, but I'm not for sure. So there's not a maximum. Okay, this graph right here, it has a maximum, but it doesn't have a minimum. Same thing applies. It's really close to 0, but it's not happening at 0 because of the open circle. Everybody understand what that looks like? So here's what extreme value theorem says. Given what? What had to be true about these graphs in order for us to have a maximum and a minimum? It's got to have endpoints. Somebody said that, endpoints, right? I've got to have endpoints. This one didn't have endpoints and it threw me off. Okay? And so that's closed. It's got to be closed. That means it has endpoints. Given a closed, what else do I need to be? Continuous. Given a closed continuous function on some interval, there must be an absolute maximum and absolute minimum. Absolute just means it's bigger than everything else or less than everything else. That is the theorem. It's pretty easy. Okay, here's what it says. Make a dot. Draw a continuous line. Make another dot. There has to be a point that is bigger or equal to every other point. There also has to be a point that's less than or equal to every other point, no matter what you draw. Okay? If you draw a line that's closed and continuous, this is the lowest point. That's the highest point. Done. The one that everyone will try to draw is this one. Oh, imagine I could draw a good line. Does that graph have a maximum? It does. It's closed and continuous, so it has a maximum. Where is the maximum? Everywhere is a maximum. Where's the minimum? Everywhere, because it's less than or equal to everything else, and it's also greater than or equal to everything else. So it's both got a maximum and a minimum. So extreme value theorem is super easy. They won't ask these on free response because it's so easy. Closed continuous, you got maxes and mins. That's what it says. All right. Down below, we have absolutely done this before. We could have totally thrown this in the last chapter. Okay. Actually, we did this last chapter on that Big Ten review. Okay. We are finding the absolute maximum value. That's the most important or the biggest difference from what we've done so far. Find the maximum value on that interval from -1 to 2. If I want to find a maximum, what do I need to do with this function? Take the derivative. So let's do it. F prime of x. If I'm taking the derivative here, it's 12x cubed minus 12x squared. I took the derivative. Alana, what do you think I need to do next now that I've taken the derivative? Yep, both. Set it equal to 0, simplify. I'm going to factor this thing. So we set it equal to 0. We notice that they both have a 12x squared, so we could take that out. And I'd be left with x minus 1. If I solve, I get x is equal to 0 and x is equal to 1. Everything we did last chapter. There's nothing different than that from 3 weeks ago. We good to there? Now what? Sign chart. What's going to be true about that sign chart? It has endpoints. This is the key to today. Okay, everything we're doing has closed interval. Because if it doesn't have a closed interval, we're not guaranteed maxes and mins. So a closed interval, we're going from -1 to 2. The other numbers we're throwing on here are 0 and 1. This is an F prime sign chart. Okay, don't forget about that. This is F prime. I need to plug in some numbers. So plug in -0.5. If I plug in, what am I going to get every time I plug into 12x squared? I'm always going to get positive, so I don't care about that. Okay, -0.5 here. Oh, it's going to be negative. Something between 0 and 1, like 0.5. Oh, yeah, that's going to be negative. And a number between 1 and 2, like 1.5, positive. Hey, guess what? It didn't change signs at 0. Does that make sense? Yeah, because it was squared. It's 12x squared. It's not going to change signs at 0. We knew that. Everybody good what we did so far? No different than what we've done. The only difference is this ending part. We're finding the absolute maximum value. And so what we're going to do is find the value. When we talk about value, that means the y value. All right, so we're going to make just this most basic chart of all time. We're going to have our x values, and we're going to have our y values, our f of x. Where could I have a maximum or minimum here? -1. Where else? 1 and 2. What I did is I just went through here, and definitely always going to list the endpoints. You could list 0 here if you really want to, but 0 is not going to be a max or min because it didn't change signs. 1's the only other one. Using our brain here, what is -1 going to be? Is -1 going to be a maximum, or is it going to be a minimum? Let's see. So think about it. You have some point, and then f prime is negative. Oh, that means I'm going down. And then I'm going down some more. Oh, now f prime is positive, so now I'm going up. So this is a max. This is a min. This is a max. But we're going to check it here anyways. We're going to check it here again. Everybody good to that point? We're going to plug in. So we are taking these numbers and seeing what the values are. So what am I going to, which equation am I plugging -1 into? The original one. I'm plugging it into this guy. So I'm plugging in 3 times -1 to the 4th minus 4 times I'm not going to write it there. That's too ugly. Sorry. I'm going to do it over here. Negative 1 to the 4th minus 4 times negative 1 cubed. That's 3 minus or plus 4. I get 7. Then I'm going to plug in 1. That's 3 minus 4. It's negative 1. Plug in 2. 2 to the 4th is 16 times 3 is 48. 2 cubed is 8. 48 minus 32. I get 16. The question was, find the absolute maximum value. What is the answer to that question? What is the absolute maximum value? It is 16. Okay? The absolute maximum value is 16. Where does that maximum value happen at? At x equals 2, but that is not the value. The value is 16. Where does it happen? It happens at 2. But understand the difference between the question. They could ask either one. They could say, where does it happen, or what is the value? You just got to pay attention to what they're doing there. Make sense what we did? It's not that crazy. It's pretty much the same thing we've done every time. Just so you can see a visual, because I want you to understand what we're doing. Here's the graph. Here's the graph. It's on the interval from negative 1 to 2. Here are my endpoints. Oh, yeah, negative 1, 7. That was a max. Here was 0. That was nothing because it kept going down. There's the minimum at 1, negative 1. But that's the maximum I really want. It's 216. It's at the endpoint. Okay, good? Cool. That's easy. That's why I'm able to throw a little bit more challenging one on the next one, because that was what we've already done. Let's go to the next one. Find the absolute minimum value of this function, 2 sine x minus x, on the interval from 0 to 2 pi. What do I need to do with f of x in order to find the minimum value? Derivative. And then you're going to put it on a sign chart. My sign chart is going to go from 0 to 2 pi. You got to remember your unit circle here. Okay, your brain might hurt a little bit. That's okay. Take the derivative. Try to figure out when it's equal to 0 here. See what you can do with your neighbor without me just telling you. Go. Here we go. So we're taking the derivative. Taylor, what's my derivative going to be here? 2 cosine x minus 1. Good. That's her derivative. She's going to take that thing, make it equal to 0. We're going to solve, so we're going to add 1. We're going to divide by 2. And then I'm going to solve that. When is cosine 1/2? Okay, so think about your hand trick here. Pi over 6, pi over 4, pi over 3. At pi over 3, I'm doing cosine. Cosine is going to be 1/2. Okay, right there, the ordered pair is 1/2, comma radical 3 over 2. If you've forgotten it, then remember it. Okay, cosine is 1/2. So that's one of my answers. X is equal to pi over 3. That is a place where cosine is going to be 1/2 in between 0 and 2 pi. It's going to happen again. In what other quadrant is your x going to be positive? The 4th quadrant, because over here it's negative because I went to the left. So the only other time is in this quadrant right here. And if I want to have the same ordered pair, it's that guy right there. It's 1/2, comma negative radical 3 over 2. They're both going to have 3 on the bottom. In the 4th quadrant, remember, it's 1 less than double your denominator. So if I double the denominator, that would get me 6. It's 1 less than that, so it's 5 pi over 3. These are the 2 values I'm looking for. If you don't believe me, break out your unit circle. But you won't have the unit circle on the AP exam, so you got to get better at it. Now I'm plugging in. Okay? It's a little bit challenging here. You got to use your brain a little bit. Okay? I got to plug in something. I'm going to do the easiest possible way, and maybe this isn't easy for you, but it's easy for me. Okay? A number a little bit bigger than 0. Okay? You could do lots of different things. I'm going to pick 0.1. What is the x value going to be when I plug in 0.1? Think about that. Here's the graph. Right there, the x value is 1. Right here at 0.1, is the x value going to be big and positive or close to 1? It's close to 1. So it's 2 times 1 minus basically nothing because I'm plugging in 0.1. Here it's going to be positive. Okay, if you don't believe me, there's lots of different ways. The way I just said it, as I look at your eyes, you all hate me for it. So don't do that. Okay, pick one that makes more sense to you. I need to pick one now between pi over 3 and 5 pi over 3. What's the easiest number to pick between pi over 3 and 5 pi over 3? I would plug in pi. Because if I'm plugging in pi, it's 2 cosine of pi minus 1. Okay, cosine of pi, oh, that's negative 1. Times 2 minus 1, oh, that's going to be negative. And really, if you just do that one, you can assume the signs are going to change. What's the sign going to be out here? It's going to be positive. Okay. When in doubt, use that method. It's increasing, it's decreasing, it's increasing. That's a min. That's a max. That's a min. That's a max. To make our final answer here, we're going to make a chart. I want the x values and the y values. I want to do absolute minimums. So if I really want to do absolute minimums, the only two numbers I need to check are 0 and 5 pi over 3. Okay, you can put them all on there. This one's so ugly. I think I'm just going to go with 0 and 5 pi over 3. That way the rest of my graph doesn't get crazy. I would normally suggest you trying them all. But because of this one is so weird, I'm just going to leave with 0 and 5 pi over 3. What am I plugging 0 back into? The original. So if I plug it back into the original, it's 2 times sine of 0 minus 0. What is sine of 0 going to be? That's 0. This is 0. Deal with it. All right, 5 pi over 3. If I'm plugging in 5 pi over 3, it's 2 sine 5 pi over 3 minus 5 pi over 3. Yep. This is going to be my absolute minimum. How do I know that's the minimum? Well, because this is negative and so is that. We could get an answer, but it's a free response question. I'm going to put a box around that, call that my absolute minimum, and move on. It's less than 0. That's what I know. When does it happen at 5 pi over 3? What is the minimum, that thing right there? Don't be concerned that that problem was weird, okay? You can do the math. That's what I wanted more than anything else. We found the critical points. We found the end points. We made a chart. That's what we did. Questions on B? Let's go to 2. Example 2 says find the min and maximum velocity on this question. Find the minimum and maximum velocity of this particle from 0 to 3. Maximum velocity. They gave me position. What am I going to have to do with position to find the absolute minimum and maximum velocity? The second derivative. You got to do the second derivative because I got to find the derivative of velocity to find the maximum minimum of velocity. And they only gave me position. Start doing that with your neighbor. See what you can do. Go. So we're finding minimums and maximums of velocity. So to do that, we had to find velocity first. And then if we want to find min and max of velocity, I have to take the derivative of velocity. I get that. Once I've done that, Luke, what do I need to do next here with acceleration? Yep, factor out of 12. So if I factor out of 12, I get t squared minus 2t plus 1. What did you factor that into? Yep, t minus 1 and another t minus 1. And I like what he said there. That is t minus 1 squared with that 12 in front. Okay, that square will help us out in a second. I'm going to set that equal to 0. Obviously, what's my t going to be? 1. Okay, we're taking that. We're putting it on a sign chart. This is an acceleration sign chart. I'm checking it from 0 to 3. The only other number I care about is 1. Is the sign going to change at 1? No. We know that already. We know it's not going to change at 1 because it was t minus 1 squared. Using your brain and thinking your way through that will help you avoid mistakes later on. But let's plug in. If I plug in a number between 0 and 1, like 0.5, that would be negative 0.5, and I'm squaring it, so it's going to be positive. And if I plug in a number bigger than 1, like 2 squared, yeah, it's going to be positive. Both of them are positive. So which one of those two numbers is going to be the minimum? Is it going to be 0 or 3? 0, because I'm taking a value, I'm increasing, and then I'm increasing some more. Okay, because A is positive. So this is a minimum. This is a max. All I have left to do is make a sign chart. Or not a sign chart, but just a chart. X and f of x. I'm checking 0. You can check 1, but don't check 1. The signs didn't change. It's not 1. 0 and 3. If this were a test day, I'm going to check 1 in case I made a dumb mistake and it was the smallest value. And I could at least say, hey, I did something wrong. But I want to check 0 and 3 for sure. What am I plugging these back into? Which equation? Position, velocity, or acceleration? Velocity, because I want to know the maximum velocity. So if I want to know the velocity, I better plug into velocity. So I'm plugging into this equation right here. This is my velocity equation. If I plug in 0, I get 0. If I plug in 1, I get 4. If I plug in 3, anybody do that one? It's 48. I think it's 48. Let's double check that. Mental math is hard. 4 times 3 cubed minus 12 times 3 squared plus 12 times 3. 3 cubed is 27 times 4 is 108 minus 3 squared is 9 times 12, that'd be 96 plus 36. Yeah, it's 48. You're good. Max and mins. This is the maximum value. When does it happen? At 3. This is the minimum value. When does it happen? At 0. Just pay attention to what they asked for. Questions there? Let's look at the next one. We're going to go kind of quickly through here. My last class, I let them work, but I think we're running out of time. So let's do it together here. Okay, when in doubt, I'm going to graph it out. So I got a table. I always like putting it on here. 0, 0. At 1, I'm at 1, 2, 3, 4. At 2, I'm at 5, 6, 7. And at 3, I'm back to 6. Here is our table. Which of the following statements must be true? By intermediate value theorem. Ooh, they gave me the theorem. Intermediate value theorem. There has to be some value between 0 and 3 where the y value is equal to 1/2. If I've got this point and this point, is it true that I have to be equal to 2 at some point on this graph? Yeah, but no. Yes, that would totally be a true statement, but what did they not tell me? They didn't tell me it was continuous. So since they didn't tell me it was continuous, 1 is not true. If it said continuous, great, it's true. Didn't tell me that, so it's not true. Number 2 says by mean value theorem. All right, mean value theorem, that's what we learned Friday. That tells us that the derivative needs to be equal to the average rate of change. There's the C, where the derivative is equal to 2. So in other words, they're saying the average rate of change is 2. Well, average rate of change, that would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I get 6 over 3. Oh, cool. The average rate of change, the slope between those two lines is 2. So does the derivative have to equal 2? Yes, but no, because what did they not tell me? It's differentiable. It has to be differentiable. That's the rule. It didn't say it was differentiable, so it didn't work. Number 3 says by extreme value theorem, there has to be a C such that, okay, so we're doing intermediate or extreme value theorem. That says closed continuous, you got maxes and mins. Such that there's a y value that is less than or equal to every other y value. So what is that saying? If there's some y value that's less than every other y value, what is that telling you? There's a minimum. Is there going to be a minimum in between 0 and 3? Yeah, maybe, but It didn't say it was continuous. It has to say continuous. The same reason why part 1 broke, this one's going to break as well. It did not say continuous. If it said continuous, great, but it didn't, so not. You got to have those things on each one. Yes, ma'am.
So when they give us like mean value theorem and extreme value theorem, they're not expecting us to imply that it's already continuous.
Yeah, correct. So, yeah, we don't know that it's continuous or differentiable by anything else. They have to state it, or otherwise we don't know that. Good thought. Look at number 4. Disregard the open and the open part here because I made a mistake on there. But don't look at that and answer which one of those is true. Talk with your neighbor, see what you can do. So we're trying to figure out which one of these is true. This is very much a free response question on the AP exam. Show me with your fingers. What do you think? 1 for A, 2 for B, 3 for C, 4 for D, 5 for E. What you got? We got a couple. Let's check. Letter A, there is some C value where the Y value is equal to 0. Is there anything in that problem that tells me what Y values are going to be? No, they didn't tell me any Y value, so it's not A. Letter B says there's some number that the Y value is less than A is less than B. That's weird. But in other words, they're saying this, that the Y value is getting smaller each time. It doesn't say that. What would it have to say for that to be true? Decreasing. It didn't say anything about decreasing, so B doesn't work. Letter D says there is some place where the derivative is 0. Did it tell me it was differentiable? So I definitely can't answer anything. If it doesn't tell me differentiable, then anything with a derivative in it isn't going to work. Okay, same thing on E. Some place where the derivative is equal to the average rate of change. Oh yeah, that's mean value theorem. The derivative has to be equal to the average rate of change. That's what that is. So does this one work here? No, why not? Didn't say differentiable. The one that works here is C. There's some number on that interval where the Y value is greater than everything else. What does that mean? If the Y value is greater than everything else, what's that going to be? A maximum. And that one is true by EVT because it's continuous and it's closed. Extreme value theorem says you got to have a max and a min.